For code. We're going to first go over an explanation using, I guess, real life inheritance, and then we're going to move on to how that's not necessarily an accurate representation of what happens in code. So we will use code instead. So first, let's take, say, a grandparent or a just a parent class. For this, let's call this class father. So generally you'd think that we can inherit things from our fathers and our mothers. We can inherit things like eye color. So we're going to make it a private, and then we're going to say eye color. And we can also inherit other traits like hair color. And perhaps we can inherit some actions, something that our parents can do well that we can as well, in a sense. So it's going to be a public method, and it's going to be called write well. Maybe our father is able to just write well. Now this is going to be a string, and then this will be a string as well. Now, we can look at a son or daughter, and we can say this will be a offspring. And what happens with inheritance is that anything that the parent class has, then the child class will inherit. It will be able to use. And we use this open triangle to represent this. Now, we could say, rather than just father, we could say son here, and then we could also say daughter. Now, what happens to those values, in a sense? So these are not instances of an object, these are classes. So for a class, if the father class has eye color and hair color, then the son class will also have eye color and hair color. What happens if I create an instance of the father class that has eye color black? Does that mean that son has eye color black? Well, in real life, that's probably how you would look at it. But in code, that's not necessarily what we mean by inheritance. It's not the instances of themselves that are inheriting anything. It's just the classes are inheriting different variables and different methods. Doesn't mean that the values are inherited, but in a sense, the methods themselves are. Now, interestingly enough, if you were to create instances of son, you would also end up with new instances of father, in a sense. So this doesn't mean that just one instance of father has a bunch of sons, just like we would in real life. It means that any kind of son can be cloned. And every time that we clone, we create a new son, we're also creating a new father at the same time. So you see how this sort of relationship doesn't really make sense, because we think of inheritance as real life, but when it comes to code, it doesn't quite work that way. So instead, we're going to change this, and we're going to say a parent class is really just an abstraction of some concept. So if we were to look at a car company or a company that creates some sort of vehicle, then we can say that the most abstract concept that this company will care for is vehicle. And this vehicle, or at least all vehicles, regardless of what kind of vehicle it is, but at least all vehicles will have a model name, and will have a year that they were created in, and perhaps they will also have some sort of capacity, some amount of people that they can carry. Now, all vehicles are going to be able to do this. So this abstraction for the vehicle really works in this sense. Let's say that our vehicle company would like to create different kinds of vehicles. So the next level of abstraction that we can think of would be a car and maybe a motorcycle. Now, in this sense, any class that now extends vehicle will any class that extends vehicle will inherit or will automatically already have model year capacity variables because you've created those in vehicle. So motorcycle might have its own instance variables that you'll be able to use or you will need. So a motorcycle will have something different than, say, a car. And this would be the only reason why we would create two different classes here, something that differentiates them. So in this case, say a car will definitely have window type. And because motorcycles don't have windows, then maybe we can find some other thing that they could have. In this case, a motorcycle will have, say, a handlebar material. Now, a car, in this case, will end up having a model, a year, a capacity, and a window type, and a motorcycle will have a handlebar material, model, year, and capacity. So it was able to inherit some from this other abstraction that we've created. Now, a car itself is also an abstraction. So what we can do is we can go even more concrete, and at some point we will want to end up with a very concrete class. In this case, we want to say maybe there's a specific type of car that you're thinking of, so we can go Range Rover. And in here, the Range Rover might have something very specific to Range Rovers that perhaps other cars don't have. So maybe we can say off-road level, or that would be a Boolean, so we can say off-road true or false, but other cars don't even have the option for off-road. Now we would connect this as an ISA, so Range Rover is a car, and maybe we can have some other type of car, and then this car would have something completely different, and this car would be a race car or F1, let's say. Not very realistic, but maybe this company makes F1 cars and they also make Range Rover cars. Now we would need to find some sort of property that this F1 car would have, and in this case it's definitely not going to have an off-road property. We would never have to worry about that, but it would have some sort of like turbo capability, let's say, and maybe we can call it int, the amount of turbo that we could have. So we go over here, we connect it, and we make it an ISA. So now we would say F1 extends car, car extends vehicle. If you were to create a class F1, you would just make it extend the car, and again, you would make car extend the vehicle. So anytime that you make F1, it's going to inherit window type from car, but it's also going to inherit model, year, and capacity from the grandparent class. So in this sense, we are receiving some properties from our parent classes instead of inheriting very specific data like what hair color your father has. So this will help us reduce the amount of code that we need, and it also helps us organize objects into very sort of neat encapsulations of data. Things that F1 needs will only be in the F1 class, and things that Range Rover needs will only be in the Range Rover class.